All right, this starts off exactly the same as what we did in algebra today. You can see it's literally the same. It's find x-intercepts, find y-intercepts. But the thing is, we want to make our graph even better, so we're going to make it even more accurate by finding the axis of symmetry and the vertex. Okay, so let's start with the x-intercepts, right? We plug in 0 for y, so here's my equation. Like this equals y, so I'm going to write instead that this equals 0. Okay, so I'm going to solve by factoring. Okay, this is what this is called. It's called solving by factoring. So I'm going to factor this part, right? I'm ignoring the equals 0. So I need two numbers that multiply to negative 12, add to negative 4. Right away, when I need two numbers that multiply to a negative, I'm thinking, I'm going to need a negative and a positive. And then I need two numbers that multiply to 12, so that could be 1 and 12, it could be 2 and 6, could be 3 and 4. And since one's positive, one's negative, I need two numbers that subtract to 4, that's this. So, and I'm going to make, since I want them to add to negative 4, I'm going to make the larger number negative and the smaller number positive. Okay, now I say, oh, this number times this number equals 0. So either this number must equal 0 or this number must equal 0. And when I do the math, I get x equals negative 2, so that's negative 2, 0, right? I plugged in 0 for y, so the y is going to be 0, right? Like I could have filled this in right off the bat, same as I can fill in this 0 right off the bat. And then here I get x equals 6. Okay, so I have my two x-intercepts. I'm going to graph everything at the end. So let's focus now on the y-intercept. I'm going to plug in 0 for x. That looks like this. This is 0, 0, negative 12, so y equals negative 12. Okay, now here's what's new. The axis of symmetry. It's the line down the middle of the parabola, right? Remember, parabola's like this. That line of symmetry is this line, okay? The answer always looks like x equals a number, right? Like this is whatever this x value is, like along this x-axis, that's what the x equals, okay? And there's actually a formula for it, which is it's negative b over 2a, right? So x equals negative b over 2a. Okay, now where's this b and a? What are we talking about? We're talking about this. Remember this? Look, a is this first number in front of the x squared, and b is this number in front of the x. So here in this equation, and look, I'm just going to copy it here just so you kind of have it as a reference in your notes, right? This is my a is 1, right? My a equals 1. This is that invisible 1 right here. This is my b right here. It equals negative 4. Okay, and now my c equals negative 12, which turns out not to matter in this case, but here are my a and b, and I just pulled them right out of the equation. A is the number multiplied by x squared, and b is the number multiplied by x. So, negative b over 2a. Okay, ready? Negative b, okay, now b is negative 4, so negative negative 4 over 2 times a. Okay, let's see. Negative negative 4, ooh, we know what to do with a double negative, that's positive. And then 2 times 1 is 2. So this becomes 4 divided by 2, which is 2. So my axis of symmetry is at x equals 2. And right away, can I tell you, like I know this makes sense, and the reason is my axis of symmetry is always going to be halfway between my x-intercepts. Right? Like, look, I'm gonna graph what I have so far because I want you to see that, like, this makes sense. And at this point, when you get the axis of symmetry, you should be able to look at your answers and say, like, oh, yeah, that makes sense. Okay, so, like, look, here, my x-intercepts negative 2, 0, and 6, 0. So I'm just going to write, and I'm just sketching. So, like, here's negative 2, 0. Okay, and now, look, I'm going to label my x-intercepts 1 and 2. So, look, that's 1. And here's 6, 0. That's 2. My y-intercept is 0, negative 12. So look, like this was 6, 0. So let's put like the 0, negative 12 all the way down here. Okay, now look, my axis of symmetry at x equals 2. Look where it is. And I'm drawing a dashed line. And what I want you to see is that it's halfway between my x-intercepts. So let's say I had gotten, like let's say I had screwed this up by mistake and I got x equals negative 2, and I went to draw the line and it was right here sitting on top of one of my x-intercepts. I would have known like something's wrong. Either the x-intercept's wrong or the axis of symmetry is wrong, right? Because the axis of symmetry should go right down the middle of my x-intercepts, and it does. And I can kind of picture what my parabola looks like right now, right? Like just with the points I have, I can picture that it's gonna look something like this, and my vertex is gonna be somewhere like here-ish. Okay, now here's the thing about the vertex. It is always, always, always on the axis of symmetry, right? Like here's my parabola, here's the axis of symmetry. The vertex is always sitting on the axis of symmetry. So this x value from the axis of symmetry, right, on this line, all the x values are 2. So the vertex that's sitting on the axis of symmetry, it's going to have an x value of 2. I can fill that in already. And then how do I figure out the y value? I just plug in an x value of 2, of course, right? If I already have the x value, I just take my equation, and I'm going to plug in an x value of 2. So instead of x squared, I'm going to write 2 squared minus 4, right? And look, I'm going to put this in parentheses just so you can really see where I'm plugging in. Minus 4 times 2 minus 12. Oh, sorry, I'm off camera here. Okay. So now let's do the math. x1 is first. 2 squared is 4. Okay, and I want to point out to you, let's say that I had a negative axis of symmetry, a negative number here, like a negative 3. Remember, when I do negative 3 squared, that's negative 3 times negative 3. That would still be positive 9. Okay, so just careful when you're squaring negatives. It's always going to equal positive. This is negative 4 times 2. That's negative 8. And then negative 12 minus 12. All right, let's do the math. Let's just do one step at a time. 4 minus 8 is negative 4 minus 12. Negative 4 minus 12 is negative 16. So my vertex is at 2, negative 16. And that's about right? Like here, this was 0, negative 12. So 2, negative 16 is like maybe something like this. I'm going to label that number 4. And then watch what I'm going to do. Estimate reflection of y-intercept. So like, see this point right here? I'm going to say, okay, like here's the axis of symmetry. If I were to just flip that point over here, it would be right there. And why am I doing that? Just to make my parabola neater, a little bit easier to draw it that way. And then go ahead and sketch your parabola. And it looks something like this. Look how pretty that is. Okay, when I was able to do this with 5 points in the axis of symmetry, it comes out really nice and neat. All right, so that's what you're going to do. And you're going to do for the practice problems, you're going to use this workspace on the back, and you're also going to enter answers into Edge Elastic so you can get some feedback and answer checks.